So basically, the agent, all is need is set of tools and an LLM and few agentic parameters. So why it need tools when I explode is tools are basically acts as a peripherals to the LLM. So LLM here core component of the agent. It will take the help of tools to fetch the data or perform few operations and use LLM to process the language content. So the agent that I created is purely supported by LangChain community and LangChain core. So the fake list LLM is part of the LangChain core. So fake list is basically which has the fake implementation of the actual LLM. The agent actually accepts the LLM object reference here. Because we need tools, I create fake tool here and give some random explanation for this. Now we initialize this fake list LLM as a multiplication, just a hard coded value. Whatever input we give, the final answer will be 42 always. This is how the agent is initialized, and this is part of this LangChain community. Once we install the LangChain core and LangChain community, we'll be able to get access to this initialize the agent. Once the agent is initialized, we can use agent to execute any input that we can. I'm invoking it with hard-coded input, what is 7 times to 6, and the answer will be always 42 because the LLM is fake LLM. So let's try and see how it works. So we get few warnings, no need to worry about that. Those are usual warnings from the LangChain. And in the response, the output is 42. As soon as we did this invoke, it went to this LLM and got this answer as a response, and it returned as it is. If we give it here something else like 55, it's always 55 because as we hard coded, and that's how fake LLM works. So now let's jump into a real-time agent that I built to freely available online APIs like SerpAPI. So this is a real agent dependent on SerpAPI. It's an online available tool and supported by LangChain community. Let me go to the agent initialization part so that we can actually the things in how they are actually connected. It needs a tool. So the basically the tool is actually search and summarize tool or summarize tool function. And here we have a search object which actually fetches the result for a given query. So this search is again a search API, SERP API wrapper, which should be initialized with API key. So here we need to give the token. If you're trying out with the SERP API wrapper, so you need to register and get a license key. And let's go back to the initialization part. And once the search results, so the SERP API will fetch the results for the given query. Once we have the results, what it does is it calls a summariser chain, which is a lang chain, where internally it processes the given data with the given LLM. This LLM chain is initialized with LLM. So this LLM is nothing but chart open AI reference, which is also supported by LangChain. So this chart open AI accepts, and we need to register a key, API key, and give it here. And we need to give its base URL. So here I'm using a open router. Because I'm using a open router, I get an API key from open router. Similarly, if we are moving out to some other API, LLM API, so we can have it here like OpenAI from GPT or anything from Llama. So we can have the URL here and put the registered API key. It also has a flexibility, select which model it needs to use internally. Whatever base API URL we give here, so that internally uses this LLM and process the data. So that's how the inference works. And LLM reference within LangChain initializer and a prompt. That's what is summarizer chain, LangChain reference, and it runs the snippets. So what is snippet is the response which we got from SerpAPI. So they will get passed through the snippet. They will be passing it to LangChain. Once the snippets are here, and the LangChain has also a reference to the prompt. So let's go and check what prompt is. Here the input variables are snippets. Whatever results we got from SerpAPI wrapper, so that will act as an input variable, and rest all is a prompt. So here we can clearly see, so we are instructing in this prompt that you are a search assistant summarizing news articles. We are asking it to summarize it based on a few key themed trends, positive and negative sentiments, etc., etc. So that's how the LangChain process the data which is given it with respect to the prompt. As soon as we trigger the run, agent runs the input prompt. First, it looks for the tool to fetch the data, then takes the help of LLM to summarize it or whatever is asked as per the input prompt, and it generates the output. So that's how agent handles different peripherals in the form of tools and with the help of LLM. Let's run this and see how the output looks like. So the agent is running. So here we can see few warnings from LangChain. So we can ignore that for now. It won't stop our experiment. So it is running this latest news about Vision Pro. So this is the response we got from the SERP API. Let's go with another open source API, DuckDuckGo engine as well. So this one is open, so open API. So we don't need to get any registration key. Uh, Other part remains same. We have chart open AI, same like SEP API engine and initialize, and I'm giving the same prompt. And let's see what would be the response. There are few warnings again from LangChain community. So here agent is processing it. Yeah, here the response is. We can actually compare both the responses because both have two different search engines. Here it has given me like in a paragraph, whereas here the description is completely briefed in different points. Here the inference system for me is openrouter.ai. Inference is completely remote and there won't be any code execution in our local. Only the request that is sent to the inference endpoints, that's what our code does. Rest everything is handled in remote, whatever inference tool we choose, like openrouter.ai. That's it with this demo.